Professor Myo Thant and Professor Su Kyi. The topic is Geohazard and Geoenvironment of Myanmar. For participants, if you would like to write down your attendance, we will distribute the in the middle of presentation, so be patient. First, I would like to introduce, we have two outstanding researchers here from Myanmar. And first, I would like to introduce Professor Myo Thant. Before we start to present his talk, I would like to read his curriculum vitae. Professor Myo Thant, now he is a professor in Department of Geology, University of Yangon in Myanmar. He also serves as a vice president of Myanmar Earthquake Committee and also as an executive committee member of Myanmar Geoscience Society. He holds bachelor from Mandalay University and master from also Mandalay University. And then he obtained Doctor of Engineering from Universitas Gadjah Mada in 2009. During that time, he also conducted research in a Disaster Prevention Research Institute of Kyoto University because at that time his program was on SafeNet with JICA sandwich program, and well, he has a very long curriculum vitae actually with work experience as a lecturer in University of Yangon. He also writing papers, particularly relating to the tectonics and geology here. And then today, yeah, I think I will not mention all of the papers because it's very how to say, very long and very outstanding from his contribution in the research of the earthquake geology and earthquake engineering. Okay, today he will talk with title "The Active Tectonics of Myanmar and Its Environment and Seismic Hazard Potential." I think after Professor Myo Thant, and then we will continue to our second presenter, Professor Su Kyi, after talk from Professor Myo Thant. Okay, Professor Myo Thant, you have approximately around 35 to 40 minutes to give a talk. Time is yours. Thank you. Professor Myo Thant?
Yes.
Okay. Yeah, time is yours.
Okay,
Please.
can you hear me?
Yeah.
Okay, thank you very much for your introduction, and also we are very grateful to invite us for presenting our research works. So actually, one of the computer already organized, power is already off.
Yeah.
This is the second computer. So my topics of my presentation is the active tectonics of Myanmar, its environs, and also seismic hazard potential from these tectonic environments. So this is the outline of my presentations. Introduction. So just only 4 parts: introduction, active tectonics of Myanmar and its environment, and also seismic hazard potentials. And then I will summarize my presentations. So as you all know, this is the tectonic regime of Myanmar and its surroundings. So the main contributing process is the subductions of Indian plates with the Asia plates. So due to this tectonic process, the consequence are, how can I say, tectonic movements of the rainfall, and also some of the faulting in the western ranges, the Burma plate, and also some of the seismic in the Shan Plateau regions. So these are the main tectonic environments, especially active tectonic characteristics. So this is the main regimes that can contribute the seismic hazard to our country. So based on the tectonic characteristics, we can divide it 5 tectonic corridors. Those are Indian Asia convergent plate boundary. This is the first one, and the second one is crusted faults or Indo-Burma range and central lowland. The third one is Gai fault, and the fourth one is translate faults regions present in the Shan Plateau and Indochina regions. So the last one is Andaman extension zones. So these are the 5 tectonic corridors that can contribute high seismic hazards to the Myanmar country. So I would like to explain the 5 tectonic corridors. That one is Indian Asia convergent boundaries. So this is the first corridors. So actually, this corridor is, how can I say, most controversial issue among the seismologists and geologists. So some of the scientists assume the subductions of Indian, the Burma plates already end. Some of the seismologists assume this is still active. It means still subducting under the Burma plate. So the rate of subduction is about 36 millimeter per year. Sometimes assumes 3 to 4 centimeter per year. So you can see the right figure. So it represents the Arkan Trench, sometimes called Burma Trench. This is the northern continuation of Sunda mega tracts. So and then gradually changes to the continent-continent collision zones in the north. So as I mentioned before, Sunda mega tracts continues to the north at the Arakan or Burma tracts, especially in the western coastal region of Myanmar, sometimes at about 22 degree north latitude. So it gradually changes to the continent-continent collisions. And then these tectonic regions end in the eastern Himalaya syntaxis and then continue westward at the Indian-Asian collision zone as main boundary tracks. So as I mentioned before, the rate of convergence about 3.6 to 4 centimeter per year. Some scientists assume until 4.7 centimeter per year. So the second tectonic region is the crusted faults located in the Indo-Burma range and also central lowlands. So I show the right panel, the right figures. That one is some of the crusted faults in the eastern highlands, western ranges and central lowlands. So the main faults located in these regions are Kaladan, Yau, and also Chin Naga Trust, the Tichang Fault, Gabor, Gwiju, and also West Baguio Mass. So most of the faults are nowadays look like correspond to the seismic behavior, but some of the faults are still thrust systems that belongs to the subduction of convergence of Indian and Burma plates. So all of these 4 systems are mainly the consequence of the Indo-Burma plate convergence. So the third tectonic region is the Rhine fault. Actually, this is the most prominent seismogenic source in our country. So you will see the right panels, the right figure. This is the characteristic of the fault. So the length of this Rhine fault is about 1,200 kilometers, running nearly north-south. So in the south of the fault, I will explain the detail in the later slide. In the south, so look like a hostel, and also in the northern part, ended in the also compressional hostels. So that tectonic region is the seismic faults lying in the Shan Plateau regions. So in these regions, can differentiate 2 types of faults. The first one is north-south trending right lateral seismic fault, and the second one is nearly northeast southwest, nearly east-west trending left lateral seismic faults. So right lateral or distal seismic faults are mainly Jiaojiang faults and also Papong fault. You can see in the figure. So the main right lateral faults bounded in the Shan Plateau in the northeast is Red River fault. In the southeast is the Papong Wanchong fault. So left lateral seismic faults are Juli, Wading, and also Mumik Nanting, Lashu, and also Manglian, Gihong, Mansi, Nama Fault, Mechen, and Lanjan faults. All of these faults are sinister faults. So this is the main tectonics regions of the Myanmar and its environs. And then I will continue by presenting the seismic hazard potentials that can be contributed by the previous mentioned tectonic regions. So in these presentations, I will explain just about the future earthquake potentials with the maximum magnitudes. So how can they contribute potential seismic hazard with the maximum magnitudes and also temporal occurrences and also spatial occurrences. So in this case, I will use three methodology. The first one is the Goodeva Richter classical recurrent loss. So this is to estimate the temporal occurrences of the earthquakes, especially in the near future. So the second one is to estimate the maximum magnitude that can be expected from the fault seismic sources. So we used the empirical relationship between fault length and magnitude. In here, I show three examples. The first one is Ambraze and Zadobaks. The second one is Inui and et al. The third one is Papaza Courts, 2014. So the third one is for the area seismic sources because we can differentiate nearly three major types of seismogenic sources. The first one is fault seismic sources, the second one is area seismic sources, and the third one is volumetric seismic sources. In our cases, according to the limitation of available information, we can just only use two different types of seismic sources, fault seismic sources and area seismic sources from the convergence or Indian and Burma plate. So I would like to start with the first tectonic regions, convergence of Indian and Burma plates. This is the segmentation of megathrust from the northern continuation of Sunda megathrust and Arkan trends. So Mondel and et al. 2018, they differentiate three segments from the north of Sumatra to western part of Myanmar. So those are Sumatra segment, Andaman Nicobar segment, and Arakan segments. So the main contributed megathrust on our country will be Andaman Nicobar segment and Arakan segments, two segments. So the right panel shows the previous megathrust event from these tectonic regions. So you all of you will know. So the most prominent one is the 2004 Sumatra megathrust event with the magnitude 9.1. But in our country, I mean in the coastal regions of Myanmar, the last tsunamigenic events is the megathrust events is the 1762. This is the main seismogenic sources from the past tectonic environment. So but for Wan Yu and et al. 2014, he made megathrust segmentation as four regions. Those are Kukul Delta region, Ramarin, Dhaka, and Naga megathrust. So this is based on the geological characteristics, some of the geological characteristics. But in here, I will also differentiate based on the epicenter distribution of previous seismicities. So based on the seismicity characteristics, we can differentiate six segments. So you will notice the first node and et al. Three segments, Wan Yu and et al. Four segments. But based on the seismicities, actually we can differentiate six segments. So in the right figures, we based on the epicenter distribution. The left figure based on the Phuket depth distribution pattern of the six tectonic regions. So this is the hypocentric distribution pattern of this region. So you can see from the south to the north. So it is very different from one segment to another. For example, in southernmost segment A, so segments B and B, so it is not clear because the seismicity is very low. But in the segment C, a little bit we can see subduction characteristics, and then D to E are very clear. So clearly shows the convergence characteristics of each segment of the Indian-Burma convergent plate boundary. So this is another characteristics based on teleseismic tomography. So we can see different characteristics of the each segment. So another one is, this is the current result, collaboration of the Chinese Academy of Science and Yangon University. So all of these subduction characteristics are, how can I say, not consistent based upon the methodology and the data information we use. So until now, we cannot identify this tectonic region as the subduction zone seismogenic sources. So that is why we use the area seismic sources based on those combined information. In here, we differentiate 19 area seismic sources from convergence of Indian plate and Asia plate. So in here, I show maximum magnitude of the earthquake potentials that can be expected in the near future, and focal depth, and also annual rate of the lower bound magnitude 5.0. So these parameters are very important for the future seismic hazard assessment.
Professor Myo Thant, I think I lost signal. Yeah, I think we have lost signal here. Professor Myo Thant? Prof. Myo Thant, I think we lost around 2 or 3 slides due to a weak signal from you.
This slide?
Yeah, I think previously. Yeah, we have a lost signal from you. We didn't. Yeah, previously, I think. Previous one, I think.
This one, right?
Yeah, this one.
Sorry. So, okay, this is another alternative way to estimate the maximum earthquake potentials for this tectonic region, actually based on the age of subjective plate and radar convergence. So in here, so actually, as I mentioned before, the radar convergence in this region is above 36 millimeter to 40 millimeter per year. But also according to the, I think, circles, so the slip rate of the rainfall is 20 millimeter per year. So it means tracts belong to regions. So that is why we can propose two models. The first one is total displacement of the total rate of convergence. We can assume the other one is half of the convergence, probably 18 millimeter per year. So we can assume as the rate of convergence. So this is the age of oceanic lithospheres. You will see near Myanmar region, age of subducted oceanic plate is about 70 to 80 million years. If we use so that information, the maximum magnitude of these tectonic regions, especially area MAS04, MAS05, and also MAS06 to 8 are totally different. So the magnitude is probably about 7.5 to 7.9. But if we use seismicity, previous seismicity, the maximum magnitude of the earthquake potential is just about 6.4 to 6.8. So this is the total difference of the assumption of the tectonic regimes. So the second tectonic region is the crusted fault or Indo-Burma ranges and central lowlands. So you will see in this right figures there are several faults, but actually until now we didn't have any sufficient information about these faults. Just only a few faults, information of the few faults are known of the estimation of the earthquake potentials, especially these three faults. So you will see in the figure, right figure, so Gabor fault and also Mrau fault, we call Kaladam fault, and also West Paguyuma fault. So we didn't know yet information from the Tijong fault, Viju Trust, and also Chinaga Trust. So you will see here TCF and also GT, CND. Just only we have no three crusted fault system. So from these faults, we can expect the maximum magnitude of the earthquake potential is about 8 in the future. So all of these are, another one is from the Zagain fault. So based on the Wang Yu and et al. 2014 and also Sudraton et al. 2011, we can differentiate three major segments. So the first one, southern and also middle and northern segments. So this is the major segment. So the southern movement is actually characterized by the hosted characteristics of the fault, and the northern portion is also the hosted compositional characteristic of the fault. So that is why, based on these characteristics, we differentiate three major active faults. Major segments. But there are several sub-segments in each major segment. For example, in here are three sub-segments of the southern segment, two sub-segments in the central portion, and also about 7 major sub-segments in the northern portion. So, but based on our seismicity period, and also we differentiate three major segments, but in the southern segments, this is the southern segments, we can differentiate 4 major sub-segments. So difference with the Wang Yu and et al. Models. So from these segments, so we can expect the earthquake potentials with the maximum magnitude 7.6 to 7.8. So this is also based on the slip rate of this fault. So you will see from these segments, we have already experienced magnitude 7.3 earthquakes happened in 1929, May 5, and also 70, July 5, with the magnitude 6.8, and also 1930, magnitude 7.3, 2 major events. So another one is central portion, middle segment. So when you differentiate 2 major segments, but in our cases, we differentiate 3 major segments, major portion. So, sorry, 4 major segments. From these major segments, we can expect the maximum earthquake potential x the 7.6 to 7.9. Actually, the 7.9 region is at the seismic gap. So the last one is northern segments. So in here we differentiate 5 major, 5 major segments. Sorry, 6 major segments, sub-segments. But together with the sub-segments, nearly 13 sub-segments. From these northern portion of the Rhine fault, we can expect the maximum earthquakes above 7.7. So from these areas, we have also experienced several earthquakes magnitude greater than 7.3. The current latest event is the 2012 November 11 magnitude 6.8 event. We call the region earthquake. So this is the temporary recurrence of the Rhine fault. So based on the methodology 1, Gutenberg Richter classical relationships, you will see the lower right chart. So we can see the recurrence interval of each magnitude earthquake. For example, magnitude greater than and 7.0 earthquake, we can expect every 40 years from this Rhine fault. For example, magnitude greater than 7.5 earthquakes, we can expect every 100 years, something like that. This is the temporal occurrence estimation. So and then the fourth, Tectonic region is the crusted fault of the Champlain region, Chantinendai block. So I will not explain today every fault.
Prof. Myo Thant, we lost your voice right now. I think due to the weak signal and bandwidth. Hello, Professor Myo Thant? Yeah, lost signal, I guess. Hello, Professor Myo Thant, we don't hear you.
Hello, I think it is internet
Yes, yeah.
connection error. Yeah,
Yeah, it's okay.
I will contact to him urgently.
Yeah, it's okay. We wait.
Yes, thank you.
Yeah, during waiting, we just remind to all participants, if you want to ask questions, you can write down in chat or can raise your hand, and then we can give time for you to give a question. Bahasa Indonesia juga enggak apa-apa. So if you want to ask questions in Indonesian language or English, you're welcome. Professor Myo Thant, I think, yeah. . Yeah, we've lost his voice. Still in internet problem, I think. Yeah, while we waiting reconnection from Professor Myo Thant, we would like to remind to all participants, you can fill the attendance form that given in the chat. There will be a certificate for this online seminar, and if you want to ask questions, you can write in the chat or can raise your hand, and we give you time to give a question in English or in Indonesian language. Thank you. Still waiting. Okay, we
I'm
will wait for.
I'm asking
Yeah.
Myo Thant to use his phone. Whenever
Yes.
the questions from your side, he can answer even with his phone. So I asked him to use his phone. So please.
Okay. I think to give a time for Professor Myo Thant to reconnect again to this forum, I think is it it's better to Professor Su Kyi to make a presentation, or we just wait for him? How do you think, Professor Su Kyi?
Now he is using his phone also. I will ask him again.
Yeah.
Okay. He can or not? computer and two kanema or who who presentation လုပ်နေတာသူကတန်းတိုင်းဖြစ်နေလို့အောက်ထပ်မှာဆိုအောက်ထပ်ကိုသွားပြီးတော့သူ့ကိုဖုန်းနဲ့လုပ်ပါ answer ဖြေပါလို့ပြောလိုက်ပါ
I think we not yet get connection from Professor Myo Thant. So it's better to move to Professor Su Kyi presentation.
Let me give some suggestion. I think Dr. Su Kyi should start for her presentation. I think then after, if someone has some question, and then can ask later to Dr. Myo Thant.
Yeah, I think it's
better. I think. Yes.
Yeah. Okay. Thank you, Dr. Mai Ai. Thank you very much for your response. Okay. While we waiting from Professor Myo Thant to get the connection and get back to this forum, we would like to move to Professor Su Kyi. Yeah, I would like to read her CV first. Professor Su Kyi is a professor in Yangon University. Yeah, and he holds a Ph.D. from Faculty of Engineering, Gajah Mada University, and the sandwich program, at Department of Urban Environmental Engineering. Oh, this is Kyoto University also. Yeah, actually I graduated also from Kyoto University. I thought this is Katsura campus, I guess. Yeah. Okay. Professor Su Kyi gave a lecture in geotechnical engineering course up to now, and also he served as a consultant he was a consultant for Dana Zayan Corporate Limited in grouting works in hydropower project, and also he contributed to the resident project in Yangon in 2015. She also as a geotechnical consultant at Strata Geotechnical Investigation from 2014 up to now. As I said, from her dissertation about landslide risk, microzonation, and the mechanism of landslide in tropical volcanic area. From her CV, we saw that she conducted many research about geohazards and related to landslides. Today she will give a talk about some case studies of natural and human-induced landslides in Myanmar. Okay, Professor Su Kyi, time is yours to give a presentation.
Okay.
Yeah.
Do you see my screen?
Yeah.
Yeah, okay. Good afternoon, Papa, and all the students, alumni students too. And today I would like to talk about some case study of natural and human-induced landslide in Myanmar. In this topic, I will present about 4 case study. One is in Hakka area, and another one is Mochi Mine in Gaya State, and another one is in Taungji area, Shan State, and the last one is Pao Moon State. The one red color here is ongoing research, and that will be still doing. Wait. First, I would like to talk about the landslide in Hakka area. So, do you see my?
Yes.
Yes. Yeah.
Yeah.
Okay. This is the biggest landslide in Myanmar. that happened in 2015 July, and it is a great impact on the infrastructure. Over 500 houses have been removed from the affected area, and that research that will be done due to the urgent need of the local authorities because of the urgent remove of the house to the safer place. And that will be done by Myanmar Geoscience Societies and also Department of Geological Survey Enterprise with the former education advisor of Dr. Yin. This is the Hakka area. You can see here, it is a big western part of the Myanmar. And this is geological conditions of the this area. It is mostly composed of limestone, necrite. Pardon? Do you hear my voice?
Yes, yes.
Okay.
Yes, you can
okay.
continue. Yeah. Yeah.
Okay. After graduate from the Gajah Mada University, this is the first research I have to apply with local people. Other research are just on paper, and then it is not deal with the local people. It is my first experience of solving the problem, especially landslide. This is the point that I do investigation this landslide, and you can see a lot of house, church, and school are already destructed. You can see here, and you can also check the ground condition. There will be very many crack here, and you can see here. Here also a lot of houses, so that means no one cannot live there anymore, and it is not safe conditions. And also not only the quarter, but also along the road, you can see a lot of crack signs and very dangerous to pass through. And the main big landslide is at Mount Rung. This is the famous mountain in that area and very secret area of these races. And you can see just a very big landslide that happened. You can also see that place. There are a lot of houses at the downward portions of this big landslide. There are many crack signs till you can see at the base of this landslide area. And also there's many types of landslide, and we make some kinds of rock and soil sampling, and we differentiate the type and the causes of landslide, and we share our landslide awareness to the local people too after field investigations. And this is the one that I collected because they need the micro-zonation map to local people to remove their houses from that area. So we have to do the geological investigation, landslide inventory map, and other input factor for the zonation map. So after that, you can also check this slide. The houses sign of the this district area. You can see there is a long wooden one, and then they cut the slope, and then they constructed like that. And this is also this is one of the traditional style of this area, but you can You can see even it is not safe like that because they cut a slope, but it saved their life because no one died in that landslide and big landslide. No one died. No one is because they can know the movement from that houses. After the signs of the movement, the crack in their house, that make them the alarms, like alarm system. So the headquarters announced to do not live, and then after the next day, there is landslide. So I use the same as my thesis PhD in Kebumian University, and I did it for the landslide zonation map, and I check with the landslide point here. It is also matched with this, and then I made for the zonation map. This is the landslide has a zonation map, and also why this happened for that case. You can also see in some photo there are many cracks. It is abnormal with other landslides when I compare with other landslides. So I check for the soil engineering properties of soil in that area. And here is in the lab, I did it for the dispersion test. So I would like to share a movie here. You can see.
Yeah. Yes.
I use that soil. It is a dispersion test, and you can see a lot of clouds come from this, and then you can see very dispersed nature. You can see.
Mm.
Yeah. Within a few minutes, this is very small video, but it can reflect the nature of soil in that area. So that's why. So I stop here. So you can even long time stay happening. You can see. That can be, you can see the kind of behavior soil type different with the landslide area. That means that the soil properties are dispersed soils, and one meet with water, and also it is a very cool place. So hot and dry alternately cause the rock also very disintegrated condition. You can see here. And this is one of the factors to cause this kind of landslide. This is our group that we did for the Chin State landslide. And another one I wanted to mention is Mochima area. It is a very famous for our tin tungsten wolfram and cassiterite protections, tin tungsten mine. Yeah, it is situated in Kaya State that I mentioned here with star. And this mine was found in 1862, and since 1903, it has protections. And due to the intrusions of the granitic rock, many sedimentary rocks changed to the low-grade thermometamorphic and that carrying wolfram and cassiterite. So, but according to the human impact, I don't want to mention even human impact, but it's the mountain itself has a very high weather conditions, and also many big block upper portion of the mountain areas. So you can see 1985, 88, and 2015, 2017. There are case landslide case happened in those years. So this is 2015. 28 people died due to the landslide. You can see a lot of people due to mine protections. We cannot prohibit it by laws. So it is also one of the big block. And also when I arrived there, there is rockfall and some landslides still continuing. So one of my PhD candidate is doing his dissertations in that area. And this is my candidate. And you can see at the background, there's some edit with 5 level, I think I forgot. They are doing mining, and then it is not so much safe for housing here. So this is one of the landslides. And another one is the ASEAN project that I have done in 2018 and to 2020 up to now with the Japan Fund and ADPC, CTI, and IGES. And we did in Taungji area. There is a landslide inventory map. Firstly, we prepare for the landslide inventory map, and then we make a combine with the climate change. It is different with the previous study, and we combine all the map, and we decided where the pilot area to do the survey. This survey will be made community-based landslide risk assessment. That means we have a lot of crew to ask the people. They know where they have the awareness or not. And also we make a weighted score to that map. It is different with the previous landslide investigations. And also we have a community landslide risk assessment before we have training first. And then after that we did to the pilot quarter area. There are about 7 quarters in Taungji area. And then we did with the local people. So from the government, DGSE, DDM, and disaster DDM and DDM and other focus collaborated with Yangon and Taungji universities. They also participate in that survey. So have a landslide area, they have to know where is what is their need. What that means, they have to know where what kind of disaster resources they have, their resources when they face the disaster or not. They decide by themselves. This is written in Myanmar, but they are written in the during survey, and the answer from them. So we differentiate what we have to do, the way we have to replenish the weak point of their quarter needs. So after that, we have a discussion with not only our ASEAN expert, but also government, local authority, headquarter. We have many discussions, and then we make for the landslide risk management strategy development for the action plan. So long-term, short-term, medium-term plan, and also resource plan, capacity implementations, and policy needs. And so we draw the ASEAN guidelines that have been done in 13 February 2020 in Laos. Now we are doing in draft state. Due to COVID, we cannot continue yet. But in May, we have to finish. We plan to finish, but not yet another time meeting. But draft is already finished. And another one is the landslide in Moon State area. Have you had? And this is also a very disastrous landslide because there is flooded in the road, and also flooded in after this mine post. So most of the bus and cars are stopped, blocked here. Has spent. So this landslide swept away most of the people, bus, houses too. And also at the same time, there are many landslides happen along this. So that this is the one that I show in the photo is Dept village, and then you can see 8 a.m. Friday, August 9th, and 42 people are dead, were dead, and 47 were injured. So when we arrive there, we can see that this is a very big slide in Dept village, but you can see there's a retaining wall at the base of this slope. This is one of the facts to cause this landslide too in Myanmar. And you can see there's a impervious clay layer, the tritic soil, clay soil, and this also the upper portion is made up of highly porous sandstone. So this is one of the main factor to cause landslide. You can see the porous sandstone here. So another nearby this Dept area, but it's not hit to the houses or people, but the small mortar, but we can climb to up to the mountain. You can see the profile of what kind of compositions of landslide material you can see here. There's a spring, you can see white color. So that means that the upper portion has very porous area, and the impervious layer under this. So for that slope becomes unstable. Is the small, even a small mortar, and most of the schools are moved because you can see the rest cycle. And on the already already the corner of there are houses in the apple. We also announced to the article is not safe for the school. There is an example of another granitic area. So in moon state, there are two types. One is in sedimentary area and one is in granitic area. Another granitic area, there is a granite intrusion in the sedimentary rock, and highly weathered granite can be also sinks. So this is also one of the factor cause landslide. So now it is I would conclude it in moon state. So landslides are found in both sedimentary and igneous area. Because of the highly porous sandstone is lying on the impervious layer, there's a crucial factor to cause landslide. And highly weathered granite with border with soil, that means the weight of the granite and the saturated soil condition cause the is also a causative factor to landslide. And also during that condition, there is a abnormal rainfall, and all the landslide happen almost the same time, even one day ahead or one day behind. Most of the landslides are happen at the same time. So that means that the rainfall is also a very controlling factor, and also structural control, and also the human impact, because there is slope cutting and even they do retaining wall. That retaining wall has no drainage hole. That means it is very bad for the landslide. So in that area, we are doing now with two MSc students to do the real-time analysis system for rainfall trigger landslide in that area. And this is that today I mentioned trees, and that most of our human induced. Some are even naturally occur, but due to the impact of human, such as construction, mining or something, it is causative factor to causative factor in landslides of Myanmar. And that's all. If you have any
Okay, thank you, Professor Su Kyi. Interesting, very interesting for case landslides. Yeah. Before we move to the Q&A, I think Professor Myo Thant already come back here. For those who want to ask Professor Su Kyi about the landslides in Myanmar, please on hold first, and then we continue to Professor Myo Thant. We'll come back. Professor Myo Thant, you can share your presentation now. Hello, Professor Myo Thant. Professor Myo Thant, you can continue your presentation. Yeah, last slide was Shan Plateau region, seismic hazard potential from Shan Plateau region.
Hello. Hello.
Yes, hello, Professor Myo Thant. Yeah.
Oh, can you hear me?
Yes. Yeah. Yes.
So let's continue my presentation.
Yeah, sure, sure.
Okay.
Last slide was Shan Plateau region. You can continue from there.
Oh, Napura. How? Oh, barang temyoku.
Assume you level.
That's what I just from mention Malone. Maporo. New bomb and a cool and the local Emma. Then I have it. No? Blue mention or on me.
Masuye speaker လေးပိတ်လိုက်ပါဦး
So that's like already right. I know.
Yes, yes.
Okay.
Yeah.
So yeah, this is the earthquake hazards. It means the maximum earthquake potentials that can be expected from this Shan Plateau region. It means included in the southern part of Trinidad region. So from this region, we can expect the maximum magnitude is 8.5. That is from the river fault. Actually, this fault is the China-Myanmar border. Yeah, so this fault, so southeast fault unit. So the another one is the maximum magnitude is about 8.4. So that is from the Zhejiang fault, this one. So actually in 1912, the magnitude 8.0 occurs in this region. So this is the earthquake hazard potential from this Shan Plateau region. So this is the temporal occurrences from this region. So by seeing the right bottom corner, we can see the maximum magnitude 7.0, greater than or equal 7.0. The expected estimated recurrence interval is about 70 years. So for example, magnitudes greater than or equal 7.5 is about 110. The magnitude greater than or equal 8.0 will be about 130 recurrence interval, years recurrent intervals. This is from the Champa region. So southern part of the Myanmar regions, we have 4 main fault systems. We call the wave fault, also trending stress fault, and also Hapon One Child fault, and also 3 Pagodas fault and Yangon fault. So you will see the table. So this is the list of the information of the earthquake potentials. So the maximum magnitude is about 7.5 from the 3 faults, 7.2 from the Yangon fault. Another number 6 at the Tectonic region is the zones. It we call Adman extension. This is southern part of South Myanmar. So in here, so maximum magnitude we can expect it is it's about 7.1. This is just only based on the previous seismicity happened from 90,000 to 2011. So this is for the Gutenberg Richter classical model for the whole region. I mean Myanmar and surrounding areas. So including all of these 6 tectonic regions. So we can expect maximum magnitude 6.5, greater than or equal 6.5 is about every 5 years or something like that. Magnitude greater than and 7 earthquakes every 10 years. Magnitudes greater than or equal 7.5 will be about 20 years or something like this. This is the Gutenberg recurrence interval for the whole region. So based on these parameters, we conducted the seismic hazard assessment for Myanmar. So in this seismic hazard assessment, we just only assume the bedrock. So this is the geological map of Myanmar, USA. So the Champlain region X, most of the rocks are hard rocks like metamorphic, igneous, and sedimentary. Cambrian to upper Cenozoic, sorry, Mesozoic or something like this. So the central lowland is mostly are Cenozoic rock units, especially sedimentary rock units. And also the western parts comprise the plains and also low-grade metamorphic rocks. So all of the site conditions we assume the rod, and we developed the probabilistic seismic hazard map for Myanmar. So the left one is the PSHA map for the 10% probability of 15 years. It means 475 recurrence intervals. So the maximum peak ground acceleration is above the greater than 0.6. So most of the major cities like Yangon, Naypyidaw, and also Zagai Mandalis lines in the higher seismic hazard zone, especially along the Zagai fault. So most of the higher seismic hazard zone belongs to the Tectonic region of the first one, convergence of Indian and Asia, and the second one is the Zagai fault. The right figure is the PSHA map of Myanmar for the 2% probability of 15 years. All of these seismic hazards are presented in terms of peak ground accelerations, I mean PGA in. So I would like to summarize my presentations. So based on the seismological and also tectonics geological characteristics, we can distinguish 5 different tectonic corridors so that can contribute earthquake hazard to Myanmar. So among them, the most significant seismogenic source is the Zagai fault, which can contribute the highest earthquake hazards on our country. But because all of the major cities, especially so lie along and nearby this fault, but among these 5 tectonic corridors, the admin extension zone X, the lowest earthquake hazard, I mean, not so, how can I say, important for our country because the magnitude is also low and also the distance is a little bit far from the countries. So this is the earthquake potentials from the Indian-Asian convergence plate boundary. Magnitude is above 9.3. For the Shan Plateau region, we can expect maximum magnitude 8.4 from the Chao fault and also Indo-Burma range and central lowland. Maximum magnitude we can be expected is about 8 from the Zagai fault. Maximum magnitudes can be expected is 7.9. This is from the of the Zagai fault. So beta segment is actually the second largest city, Mandalay, is nearby this fault, this segment. So this is the upgrade recurrence interval for the whole Zagai fault. For example, in here, magnitude greater than or equal 7.0 can be expected every 40 years. Maximum magnitudes greater than or equal 7.5 can be expected every 100 years or something like that. So this is one of the examples. So it is more or less consistent with our estimation. So for example, in here, we can see previous earthquakes happened in 1946, September 12. Actually, magnitude 7.3 and magnitude 7.5 earthquakes happened continuously within about 3 minutes intervals. So in 2012, November 11, magnitude 6.8 earthquake, we call the Beijing earthquakes happened. So it means the recurrence intervals of the magnitude greater than or equal 6.5x around 70 years or something like this. So based on these case histories, so earthquake hazards potentials from this rainfall is higher and higher nowadays. I mean, the possibility of the occurrences of earthquakes greater than 7.0 its high possibilities. So thank you very much for your patience. I'm also sorry for inconvenience.
Great. Okay. Thank you very much, Professor Myo Thant. This is also very
welcome.
interesting about the earthquakes and seismic analysis in Myanmar. We guess that audience here, participants, is also have some questions or thoughts about the geohazards and geoenvironment in Myanmar. We move to Q&A sessions. First, here, probably Professor Su Kyi already noticed the question from Dr. Lucas Doni, our lecturer in Department of Geological Engineering. His question is how thick, for Professor Su Kyi, how thick is the typical weathering soil in Myanmar? So one of the photo on the large-scale rupture on metamorphic rocks shows very thin soil on top, and rupture occurred on solid bedrock. So what is the triggered such massive rock rupture? Maybe Professor Su Kyi may respond to these questions. Professor Su Kyi?
Yes.
Yeah, you can respond to this question from Dr. Lucas.
Lucas, yes.
Yeah.
Thank you for your question, Lucas. You can see in my presentation there are two. There are two types. One is in sedimentary area and one is in igneous area. So the soil in igneous area is very thick, and sometimes in Myanmar we can see the whole mountain is high, completely weathered granite. And once I do not mention in that presentation, but in Myanmar, the way is at the lower portions, like a neck of our map. In that area, the landslide happened in 1997, and then the whole hospitals are embedded with its highly weathered soils from granitic area. This is one of the history. And another one you already noticed in my presentations, a very big joint. I already shared screen on.
Okay, you may share the photos, Professor Su Kyi.
Yeah. Just right here.
Yes. Okay.
Yeah. There's a big joint. Also, not joint. I think it is already full because we can see some movement on the surface, and you can see the man standing there. Even in the upper portions, there is a very small, thin layer of soil at the upper portions, and because of the highly jointed and very porous sandstone in that area, we here you can see at the lower portion, at the corner of the photo, you can see the impervious clay layer there. So this is one of the problem in bone state. Another question.
Okay. Okay, Professor Su Kyi. Dr. Lucas, this explanation, is it okay? Yeah. Yeah, okay. I think we move to a question to Professor Myo Thant. This is also from Dr. Lucas, yeah. Question to Professor Myo Thant. Do you think subduction still exists underneath of Myanmar?
Yes.
Yeah. Maybe Professor Myo Thant can could respond about this. The subduction still exists underneath Myanmar or not?
Yes, actually, yes, earthquakes. We most of the shallow earthquakes, as I mentioned in my talk, mostly strike slip. But in the deeper oceans, most of the faults correspond to the thrust mechanism. So it means most of the cluster faults belong to the northward movement of Indian plate relative to Asia. So the deeper ocean, like 2016 Chao earthquake, magnitude 6.8, the forecast depth is about 100 kilometer. So, and also magnitude 6.8, 2016 April, we call Molai earthquake, magnitude 6.8, also thrust mechanism. So all of these events belongs to the subduction of Indian plate and Burma plate. So even though some of the scientists argued the subduction is already ends in the western coastal area of Myanmar, but based on the seismicity of our, it is still, how can I say, going on. Yes.
Yeah. Another question here from Dr. Lucas also. To Professor Myo Thant, how you classify the type of sagaing fault? Is it similar to Sumatra Great Fault in Indonesia, or?
Yes. So the Zagain fault system is also similar with the Sumatra fault. It is also right lateral. I think actually, probably we may say this is the continuation of Sumatra fault or something like this. So after passing the Edmund extension zones, so northward continuation as a right lateral system. But I am not so sure the slip rate of this Rhine fault and the Sumatra fault. So probably slip rate of the Rhine fault is about 1.8 to 2 centimeter per year, probably lower than the Sumatra fault system. Yeah.
Okay. Another question here also from Dr. Mai T.I. to Professor Myo Thant. In this recent time, which fault segment is the most dangerous and active in Myanmar? How do you think, Professor Myo Thant?
Yeah, actually, we can say beyond 2012, November 11, magnitude 6.8 segment. So we can see all of the segments are very, how can I say, dangerous, especially in the southern segment. I mean, we have differentiated 3 segments. So southern segments like Bagu segment or Pew segments.
Professor Myo Thant, sorry,
Actually,
can you show the slide of that segment?
yeah. Sorry.
Yeah.
Okay, I will.
Yeah.
Thank you very much for your reminding me. Yes. Can you see my slide?
No.
No?
Ongoing, I think, still loading. Maybe Professor Su Kyi can stop sharing at the moment.
Yeah.
Yeah. Yeah, and then Professor Myo Thant can share the slide.
Okay.
Yeah, probably one slide that show all the segments. Okay.
Yeah. So this is the, for example, Sodamu segment. So 90, 29, 90, 30 segments. So the magnitude is greater than 7.3. So until now, so the aggregations of about 90 years. So the recurrence interval of magnitude greater than 7.3 is about 80 to 100 years, something like that. So we can see all of these segments are very, how can I say, dangerous for this area. And also these areas, we just only have already mentioned 2020, the Beijing earthquake happened from this area. So rather than these segments, all of the other segments are also very dangerous, especially the inward segments. You see March 3, 1839 events. So after these events, there are no seismic activity. So we can see this area is seismic gap, and also this segment is also very dangerous currently. Yeah. Thank you very much.
Okay, thank you, Professor Myo Thant. Yeah, we move to next questions here. I think this from a student. Yeah, my name is Alfian. So I think this is Indonesian student. Question to Professor Su Kyi. Do human activities control the landslide? And could you tell how the spring come out from the sediment rock? Is there any fault exists at that landslide?
Okay, you can see this slide. There's a. Do you find the spring on the surface of the slope? Do you find? The upper portion is composed of a highly porous sandstone that I already mentioned, and the red color that is look like a very soft clay. So with two different properties of permeability that make the stream come out from the upper portions. I don't think so. There's a fault on that surface, but the fault is here, the jointed area. But on the surface, there's two different permeability layers. Due to that case, the water pressure push out to cause the landslide. And another one, you said human factor. Of course, human factor are the main causes in some place. For example, in that photo, you can see the retaining wall at the base of the slope. But in that retaining wall, the flow amount, actually, before that, there is a natural flow occurring in that base of the slope. But after retaining wall, the amount of the amount of flow, I mean the amount of discharge rate, and after retaining wall, the amount of discharge rate will be fewer than the previous. That's why that is also one of the factors. And another one is the constructions of the road. They cut the slope in proper way. I mean, with the proper slope cutting is okay. And another one human factor is the constructions of the house. They cut the slope and then put the house on it. So on barren surface, the rainfall can easily infiltrate and also downward movement can occur.
Okay. Okay, if maybe Afian satisfied with the answers, or if you have another question, you can write down in the chat. Another question here also from Razar Lang. Question to Professor Myo Thant. This is based on Wang Yu subduction sources. The
Yes.
northern part of Myanmar or the Hakka section is more than 6 millimeter per year, and southern part of Myanmar is 8 to 28 millimeter per year. But the peak ground acceleration of northern part is higher than southern part. May we know why? Is it related with the seismic? or others, seismicity or others?
Yes. So actually, yeah, northern part of the Myanmar is how can I say, the seismic sources contributed to the area is a little bit different with the southern part, because southern part is just only, how can I say, seismic sources contributed, the seismic hazard is just only the rainfall. But when we go to the northern part of the areas, so the seismic sources are not only the rainfall, but also collision of Indian and Burma plate. So, and also the magnitude is a little bit, how can I say, higher than with the southern part. So that is why the EGA values of the north higher than the southern part. This is another, because you will see a 1950 earthquake in the northern part of Myanmar is magnitude 8.6 or something like that. And also we can see, so the northern, how can I say, the northern part of middle segment is also higher than the southern part, because the magnitude of the earthquake potential is also higher than the southern part. So this is, depends on the seismic source characteristics and slip rate or something like that. But I think the slip rate subduction of the northern part is actually not greater than 6 millimeter per year. Oh, you mean 6 millimeter? Actually, when we go to the northern part, so you will see three different, how can I say, values. So that is why we model as the two different models. For example, the largest one is the 4 centimeter per year. The smaller one is the 18 to 16 millimeter per year. So this is depends on the treat of seismic source parameters from the sources. Yeah.
Okay. I hope the answers from Professor Myo Thant satisfied Mr. Azhar, yeah. This is other questions here to Professor Su Kyi about the maybe Professor Su Kyi.
Yes.
Yeah, there's another question here. Do you see any difference in intensity of landslides or any other types of hazard in the different area of Myanmar in general? As the whole area of Myanmar is lies on the boundary of three tectonic plates and very diverse lithology from wide range of geological age. This is a question from Dr. St. Prof. Su Kyi? Hello, can you recognize the questions?
Can you hear?
Yeah. Now, yes. Can you recognize the questions? Yeah,
Okay.
from Dr. St. Yeah.
Thank you, Dr. St. In Myanmar, they are flat. Flat is also another hazard in Myanmar in mostly rainy seasons. And second is the landslide. And because of the whole country, different types of lithology and a wide range of
6 millimeter or 6 centimeters.
it is very different. But you are considering here is a boundary of three tectonic plates. Maybe in some area the effect can higher, but in some area not, cannot consider as that case. Another one is also earthquake, but at still our age there is not so much big earthquake. I didn't have experience yet, but I don't want to this experience too. Big earthquake, no? Commuter, Mr. Muta. I don't want to experience that. So three types: flat, hazard, flat, landslides, and earthquake.
Yeah, flood, landslide, and earthquake in
Yeah.
Myanmar. Okay, we still have around 15 minutes. Yeah, probably if the participants want to ask questions, you can write down in chat or raise your hand. You can ask questions in English or in Indonesian language. It's up to you. And meanwhile, we move to Professor Myo Thant. I also interest with your presentation. Related to the northern part of Myanmar, yeah, northern area of the tectonic condition in Myanmar, is there any significant earthquake happened in 2015 after the Gorkha earthquake in Nepal? Maybe you consider Gorkha earthquake in Nepal in 2015 with magnitude 7.8, more than 7.8, yeah. At that time, is there any significant earthquake following the Gorkha earthquake in Myanmar because of this kind of a relationship in the northern part of Myanmar?
Yeah, actually, I think there is no events related to the, after the Kathmandu earthquakes. Yeah. So, significance mean the probably magnitude greater than 6.5 or something like that. So, I think we don't have, but because the northwestern part of the Myanmar, that area belongs to the collision of Indian and Burma plate. So when we see the earthquake seismicity map, so you will see those area is high seismicity area. Can you see my slide?
Still loading.
Still loading.
Yeah. Maybe you can share.
Okay.
Yeah. Now it's
yes. So we can see So when we see the seismic sorry. Yeah, for example, in here, seismicities, when we compare with the other, the west and northwest part of Myanmar is higher than the other areas. So it means this area mostly belong to the subductions of, convergence of Indian and Burma plates. So we cannot identify some of the events correlated with the Kathmandu earthquakes or something like that, but it is a very little chance to relate with the Kathmandu event here. Thank you. Yeah.
Okay, thank you, Professor Myo Thant. Is there any question from participants? Is there any more questions to Professor Su Kyi or Professor Myo Thant from the participants? Yeah, probably I would like to ask to Professor Su Kyi. Yeah, related to the dispersed phenomena in your landslide cases, is it quite common in landslide case in Myanmar that the antecedent phenomena or precedence event before the landslide happened, the dispersed or dispersed phenomena appear in the landslides in Myanmar? Or this is because of the cracks, the prolonged cracks before the event? Can you explain about this dispersed? Yeah.
You mean antecedent rainfall?
Yeah, considering the rainfall.
Right? Antecedent rainfall of, yeah, of course. Most of in Pound area, there is my two students, MSc students, they are doing rainfall triggering landslide. So I found that cumulated rainfall, and that means that the antecedent rainfall 3 days and 5 days, we based on that that day, and then we simulated. So that happens because of the climate change. The rainfall is very higher than the abnormal than the previous years. So it is very clear whenever I study most of the landslide area, also abnormal rainfalls. So this is one pattern. And you mentioned the crack propagation.
Yeah.
Right? The crack
Yes.
propagations beforehand.
Before the event. Yeah. Before
The landslide. This is the initial signs of crack propagations, and the rainfall is forced to accelerate that landslide. So it is the initial sign. After they got the saturated and they have initial signs of crack and more water enter, and then they develop crack propagations more and more, and then become severe landslide.
Okay, thank you, Professor Kyi. Maybe is there any more questions here for this remaining time? Maybe the last question, yeah, from for me to Professor Myo Thant. Last questions regarding to the we had 2018 big strike slip earthquake in Sulawesi in Indonesia, which is looks like similar in the Sagaing fault strike slip. So can you share with us after there is Indonesian big earthquake of strike slip fault? Is there any story or efforts or mitigation from Myanmar to prepare for this type of earthquake in Sagaing Fault?
With that?
Shematan?
Can you see?
Yeah, loading. Yeah, you said the Sagaing Fault is quite, I would say, very long with the cities, many cities, across many cities.
Right.
Yeah, yeah.
Can you see my slide?
Yes.
So, yeah, wait a minute. Okay, for example, in here, actually we have a lot of historical events. So this is the middle segment of this Rhine fault. So the earliest event is the 1839 March 3. So previously we assumed this earthquake, the magnitude of this earthquake is just about 7.0 or something like that. But after the 2000, probably 15, when you et al, they made a seismic intensity map of this event based on the felt information around the Southeast Asian country. So based on that intensity map, the magnitude of 1839 event X, nowadays we assume about 8.0 or something like that. So due to this event, the casualties is about 400 people. So you can imagine in that year, I mean 1839 years, when we compare with the present situation, so the population and also, how can I say, the number of buildings, infrastructures are very different. And one of the case history, we need to prepare for the future events. And also the other one is here, you can see 1946 events. So you will notice on the same days, there were two events. The first one is magnitude 7.5, The second one is magnitude 7.8. But in that time, there were no records of the causality, but a lot of damage, especially related with the landslide and also subsidence. Most of the hazards related to the liquefaction or something like that. So this is also another case history. But to the southern part, southern part, as I mentioned before, for example, 1930, May 5, magnitude 7.3 earthquake caused 550 casualties. So central area was in Bago. So in Bago, casualty is about 500. In Yangon, so you see Yangon city here. So Bago is probably here. Yeah. So Yangon is in that time the casualty was about 50. So totally 550 people dead. So when we compare with the present situation, if the magnitude probably about 7.3 earthquake happens, damage properties and number of casualty probably higher than that event. So that is why, as I said before, all of the major cities lying along this fault. So we need to prepare a big event like Sulawesi event or something like that. But fortunately, when the Sulawesi earthquake happened, so also tsunami, right? Tsunami also happened. We hope due to the earthquakes from the Seismic fault, I think tsunami cannot happen, especially from the southern segment or something like that. Yeah. Okay.
Okay, thank you, Professor Myo Thant. Thank you very much.
Yeah.
Such a fruitful presentation and discussions. Here we have Professor Myo Thant and Professor Su Kyi. We thank you very much for your very interesting presentation. We learned a lot. We hope all of us participants learn a lot about the geohazard and geoenvironment in Myanmar, which looks like it's very similar in Indonesia regarding to the earthquake, landslides also with lots of active faults. Okay, thank you very much.
Thank you very much.
Thank you very much for your kind presentation and attendance. And through this, I would like to give the time back to the host of this seminar. Thank you very much, participants.
Thank you.
Thank you.
Thank you very much, Professor Metan, Professor Su Kyi. Thank you very much.
Thank you.
Okay,
Thank
Pak
you very much.
Nugroho, time is yours.
Okay, thank you very much, Dr. Hendy. Thank you very much for the presentation, Professor Myo Thant and Professor Su Kyi. And at this time, all of the schedule in our online seminar is complete. And thank you very much for your participation. And we will meet again in this special online seminar for alumni geological engineering Gajah Mada 2 weeks later. Okay, see you. Thank you very much. And
Thank you very much. Yeah. See you
from this meeting.
Have chance. We will
Thank you
meet
very
again.
much.
Anh còn liền để thì qua một hai chung là
Thank you, Dr. Myo Thant, Dr. Su Kyi.